All right, folks, so you should be making sure that the order of operations is being followed here. You think you know who's right? You think you know? I want you to put, I don't want you to tell me. I just want you to put a little star in the box. Don't tell me. Put a little star in the box so you think who's right. Here we go. If you look at this problem, what would you do first in the order of operations? Do what's in the parentheses first. So what is 3 minus 2? So Tom is correct, right? How about Li Cheng? He's correct too. All right. Well, now that I'm here, what would you do next? Would I do the multiplication, the adding, or the division? Multiplication would come next. What is 4 times 1? So Tom's right. How about Li Chen? He's right too. Now that I'm here, would you add first or would you divide first? You would divide first. So 6 divided by 8, well, is that the same as 6 over 8? So that looks okay. Did Li Chen do that? He did this first, right? Was I supposed to do that first? No. Tom is right. But you need to provide an explanation about why Tom is correct. So can you please, after you put the star in the correct box, write me a sentence that says why Tom is correct? Somebody speak it to me. Somebody tell me what they're going to write. What do you think, Braden? Instead of correct. Tom is correct because he divided first instead of adding first. Your sentence should start with a capital letter. It should end with a period. It also should be legible. When you're finished writing your sentence, go ahead and read number 2. So, if Michelle can read 1.5 pages per minute, how many can she read in 2 hours? Say it again. 1.33, not quite. 180 is correct. Can you tell me how you did that, Quentin? You want to help him out, Lucas? Luke? Go ahead. Basically, folks, 2 hours needs to be converted into minutes, doesn't it? Yes? So how many minutes is 2 hours? That's 120. So now that we know that, we will multiply. And that's exactly what Luke was telling me to do. We're multiplying. You need to make sure your units match. Fair enough? Okay, go ahead and read the number 3 there. Go ahead and read number 3. All right, so before we start answering this question, I want you to think of what an acceptable answer would be. Is the whole student body coming? No, so my number better not be bigger than what? Better not be bigger than 300, right? Are more than half coming? Are more than half coming? Yes. So what's half of 300? So they better be higher than 150 but lower than 300. Does that make sense for everybody? Okay. So how am I going to figure out how many people are going to be coming to the drama club production? Multiplication is correct. Before I multiply, this 65% right here has to be turned into a decimal. How do I turn 65% into a decimal? You gotta speak up, I can't hear you. Divided by 100. Folks, all percentages are out of 100, aren't they? Yes? So that 65% needs to be divided by 100. And what do you get? 0.65. And like Savannah said, we're going to multiply that by the 300. 195 is how many they would expect, which of course is between 150 and 300. Questions for me, folks? You sure? I think today's going to be a piece of cake for us. But we'll leave that up for debate, okay? You tell me when we're done what you think, okay? Today we're going to talk about relations. Well, I've got to tell you what a relation is. No, I'm not talking about a relationship like boyfriend, girlfriend, mom, dad, aunt, uncle. No. We're talking about a relation. A relation is a set of ordered pairs. A set of ordered pairs. I need to make sure you understand a couple things about that definition. If it's a set, that means there will be the squiggly brackets around it. There will be ampersands around it. The bird things, yes. Okay, everybody all right with that? Yes? Okay. Next thing is, what's an ordered pair? What is that? Not evens and odds, Luke? Nope, another good guess though. 1, 1 is an ordered pair. All of these things right here are ordered pairs, right? What are those things? They're on the x and y axis. We put them on a graph. What are they? They are coordinates. These things are coordinates, also called points. When you write ordered pairs, they look like this, x, y. The x must always come first. The y must always come second. How we doing, folks? Is that okay? Now, domain, I actually mentioned to you about a week ago, and I told you to keep it in the back of your head when we did those charts problems. You remember those big tables that we did with the input and the output? Do you remember those or not? Yeah? Okay. Well, I told you that domain was one of those. Do you remember what domain is? Say that again, Gage. The left side is correct. Yep. What did we call that? I can't hear you. I just can't hear you guys is all. These things cover up my ears. It is the x, yes. The domain is the set of all x's. We also called that the input, which was on the left side of your chart. Another word, correct, you are correct. That means the range must be the y, he said. Also called the perfect. Okay. Now, there's one more way we can describe domain and range. Mostly used in science. Mrs. Neary, you will hear this if you have not heard it already. And when she says it, you're going to be like, oh yeah, Mrs. Cannon told me about that, right? Okay. The input, the domain, is also the independent variable. The independent variable, which means, what's the range? The dependent variable. From who? Oh, thanks. That's right. Everybody good? We sure? All right, let's try one. Take a look at that problem down there. The first thing I need you to do is I need you to add an ampersand after that last ordered pair, because like I started the squiggly bracket, but then I forgot to close it. You got shot out of the air, yep. So can you put that ampersand at the end of that to close the set for me? Okay, so I got a lot of stuff going on in this problem. It says I need to express this relation right here as a table, as a graph, as a mapping. So right there, there's three things right off the bat. And then I have to do domain and range. So a table should be pretty self-explanatory. You all know what a table is. And you're just going to take your ordered pairs and you're going to plop them right into that table. So what will that look like? Easy enough. There's your table. Done. Done, yep. Okay, now it says I have to make a graph. Now, you don't see a graph on there, do you? You are going to neatly make yourself a coordinate plane. Make your lines relatively straight, please. It doesn't have to be perfect. Label the horizontal axis Y and the vertical axis, the horizontal axis X. Let me restart. The horizontal axis should be X and the vertical axis should be Y. Now, I'm not going to put the little hashes on them. Okay, I'm just going to sketch it. So my first one says 4, 3. Now, let's make sure we remember how to graph points here, folks. Where do I always start? The origin in the middle. The first number is the X. Which way do X's move? Or you're going to go left or right here, folks. If it's positive, we go to the right. If it's negative, we go to the... Okay, so this says 4, and that's positive. So I'm going to go 4 on the x-axis, and then that says 3, so I'm going to go 3 up. So maybe right about there. Now the next one says -2. So which way will I go for -2? No. We're going to go to the left 2, and then we're going to go down 1. This one says 2, -4. So I need to go 2 to the right and then -4 somewhere in there. And then I have 0, -4. Where do I go for the 0? Nowhere. And then -4 down. So it should look something like that. Now, I want to make sure I make this point. Somebody asked me in my 4th period class, and I want to make sure you guys get the same thing here. Should I connect these dots? No, you should not connect the dots, because when you connect the dots, you're telling me that everywhere on this line is a point. Do I have all those points? No, I only have the 4 they gave me, right? So do not, I repeat, do not connect your data points. Oops. All right, last but not least, we have a mapping. If you're going to make a mapping, you're going to make 2 bubbles. You're going to label one of them X, one of them Y. You're going to put all of your X values in the X bubble. If any of them repeat, you will not write the repeaters. Everybody good with my X's? Yes, no, maybe? Now, when I do the Y's, I am not going to write -4 twice. I'm only going to write it once. Say that again. Now, a mapping tells me I need to draw arrows that connect the correct numbers. So here, this says 4, 3. So 4, 3. -2, -1. 2, -4, and 0, -4. Does everybody understand what a mapping is? Still pretty self-explanatory, right? Okay. Lastly, I had to write the domain and the range. Domain is which one again, folks? all the x's. So I'm going to start this with an ampersand. Because I'm going to list all the x's. Now, when I do this, folks, you need to make sure you put them in order from least to greatest. Did everybody hear me loud and clear there? Okay, so what are my x's, my domains from least to greatest? Least would be -2, right? Then 0, 2, 4. It will be wrong if you do not put them in order. Now, the range is a set of all y's. So what are my y's here? In order. What's my biggest negative? And then, notice we did not write that -4 twice, folks. Does everybody see that? All right, so there it is. We've answered everything in that problem now. Good to go? That wasn't too bad, though. Agreed? It was awful. All right. Now, I made a pretty big typo on this next problem, so I'm going to fix it. If you look at this next problem, please cross out where it says increases and falls, all of that. I'm not really sure. I must have been tired when I was making up these notes. I need you to switch it to say, and falls as a daily average temperature rises and falls. Bless you. All right. So your directions say identify the independent and the dependent. Basically, that means figure out which part of this problem influences the other part of the problem. Make sense? I'm going to give you an example, and then we're going to look at this one. The more time you study, the better your grade will be. So the time that I study influences my grade. Does that make sense? Okay, let's apply it to this. In warm climates, the average amount of electricity used rises and falls as the daily average temperature rises and falls. So which part of that influences the other? Does the electricity influence the daily temperature, or does the daily temperature influence the electricity used? Temperature influences the electricity. That means the temperature is the independent, and then the amount of electricity is the dependent. Think about it, guys. When it's hot outside, you use more electricity because your air conditioner is running a whole lot, right? When it's cool outside, you don't use as much electricity because the air conditioner is not running. Well, the heat is normally propane or natural gas. Some people still have electric heat. Some people do, yeah. Anybody have a big propane tank out the back of their house? No? We have natural gas, but in the summer, our electric is high and our gas bill is low. But in the winter, our gas bill is high and the electric bill is low. All right, next one. The number of calories you burn increases as the number of minutes that you walk increases. Which one influences the other? Walking influences the calories you burn. Perfect. The minutes that you walk is the independent, and the calories you burn is the dependent. Good. Wonderful. The final parts of your notes here. You are going to look at a graph. That graph will only have a title, and it will have 2 axes. You have to try and tell me a story or a situation that represents what's going on in that graph. So, in the first graph, we have Mrs. Ling. Her room on a winter day. We have the x-axis is the time. We have the y-axis is the temperature. Can somebody describe for me what's happening in this situation? Okay, we're talking the heat. Okay, so what does she do when she comes into her room, folks? She turns on the heat. So you probably should write that. You're writing a description, right? When she comes in, she turns on the heat. So that takes care of this portion right here, right? Now, what's going on here? Go ahead, Brayden. She's not turning the heat off. She's not turning it down. Yeah, guys, how does the heat work? The heater runs, and then once it gets up to temperature, it shuts off, doesn't it? And then when it gets cold again, it turns on. And then it shuts off. And then it turns on. And then it shuts off. That's this portion right here. So you need to write that in there. Then the heater kicks on and kicks off throughout the day. You should have plenty of room underneath there to write. And then before she leaves, she turns it off, which makes the temperature go down. Wonderful. You see how we can kind of figure out what's going on just by looking at the graph? Okay. I believe the next one is the cross-country team or track team. The track team is running. The x-axis is time. The y-axis is the distance they've run. So go ahead. What's happening here? They started running. Okay, so you can start. They started running. So that gets me that portion. Then what do? They take a break. You see how that line's flat? They're not going anywhere. So then they take a break. Maybe you say they stop for water. Now, they do start going again, but I want you to be more specific. Hold on. What do you notice about this section and this section? Are they steeper or flatter, or are they the same? Steeper? I think they look the same. Okay, if they're the same, that means they start running again at the same pace. Everybody got that? So you should have they started running, they stopped for a break, they started running at the same pace. Then what happens? They are going to cool down or run slower because do you see how that line is less steep? That means they're slowing down. If it was more steep, then they would be speeding up. We're going to skip the lawnmower problem. Do you want to do the lawnmower problem? Okay, we'll do the lawnmower problem. That's all right. That's all right. Okay, we have the sales of lawnmowers. We have the time and we have the sales. This is like your time of day. Okay, so what happens at the beginning of the day? Just a few sales, right? It's not very steep, is it? So we start with a few sales. Then I don't think this would be a lunch break. Like a coffee break, maybe. That's in the morning, isn't it? Yeah, so now we don't have any sales right there. It's flat, isn't it? So they stop and take a break. Then what happens? They start selling like crazy. Maybe they run a sale. They start selling like crazy. So you guys should be writing these descriptions. Let's go. Then what happens? Probably a lunch break. That one looks a little longer, doesn't it? Probably a lunch break. You tell me. Sales are going down, aren't they? So they're selling less and then even less. So like I could put times on here. Maybe they open at 8 a.m. and they close at 8 p.m. This in here, maybe this is their lunch break. Maybe this is a coffee break. Then after lunch, they're not very busy, are they? Make sense? All right, I got one more. Student taking an exam. So describe for me the situation. We answered a few questions right here. Then we don't have to be taking a break. Maybe we're just stopping to think because I'm not answering them, right? Okay. Maybe you get up to go to the bathroom. Maybe you stop to think. Then what? Yeah. Is it the same pace? Is it faster? Is it slower? Those look about the same pace, probably. Then what happens? We take a longer break. Not during an exam. You're not eating lunch. And then we start answering your questions again. You can tell a lot By analyzing a graph. Now, that bottom portion where it says on your Chromebooks, we're going to start with that on Monday, okay? Good? Oh, of course you have homework. We're just going to do that part on Monday. Make sure that goes in your binder, and you have a worksheet that I'm going to give you right now for homework.